The learning objective for this presentation is to develop an understanding of the Cloud Healthcare Appliance Real-Time Solution as a Service, or CHARTSaaS, which is an IT software development environment for use by healthcare providers, subject matter experts, to create cognitive support apps that mitigate mistakes and optimize case outcomes. To meet this objective, I will present first an overview of the healthcare provider practice problems, followed by identification of the root cause of medical mistakes and recommended corrective action, and then the Cloud Healthcare Appliance Real-Time Solution as a Service as an IT-enabled corrective action, and finally, a call to action to all of you as prospective partners in realizing CHARTSaaS. This is the first of 8 slides depicting the principal problems inherent in the practice of medicine and delivery of healthcare. This slide depicts the problem of multidimensional scope. Notwithstanding the fact that current healthcare is more correctly described as health cure, that is, the return of the morbid patient to a nominal, if not normal, biopsychophysiological status, healthcare should be defined to include the maintenance of good health throughout one's life. Therefore, this schematic depicts 4 healthcare spectra, beginning with the womb to tomb or conception to death duration of a human individual, punctuated by episodes of injury or illness requiring medical intervention, and/or by episodes of inpatient hospital-based care and treatment. Ideally, the information that accrues during the patient's subjective and objective data collection, also known as the history and physical workup, the differential and final diagnoses, and the case assessment and treatment plan all should be archived in the common body of medical knowledge in a manner that is readily accessible for application to the next clinical case that presents. The second provider problem is the triple focus of care and treatment. Medical practice and healthcare delivery require an in-depth knowledge of the presenting patient, comprehended by the provider distinctly and separately among the several other patients currently in treatment, the patient's own presenting pathology or even comorbidities, and also the principal provider's care team members, including their individual capabilities as they relate to the presenting patient and pathology. The third provider problem is the need for time-critical actions. Not only must medical practice and healthcare delivery actions be done completely and accurately, but also in a timely manner. And timeliness is required for the intended effects of many actions taken in both the micro or internal and the macro or external environments to be obtained. Internally, human homeostasis occurs continually, driven by microbiological mechanisms that control inputs and internal conditions in order to maintain a nominal biophysiological state of equilibrium. Externally, in the visible world, conditions and circumstances change constantly too, which changes must be detected and reacted to in time to minimize morbidity. Both of these dimensions of timeliness require constant monitoring to detect changing conditions in time to maintain nominal conditions or to prevent unintentional conditions and crises. The fourth medical practice and healthcare delivery problem is that of intensive information. Medical and healthcare information typically is intense with respect to volume, variety, velocity, and varying veracity. Given these extremes of amount, type, speed, and accuracy, it is impossible for the human mind to execute the 4 activities of the information processing cycle depicted here with the required completeness, accuracy, and timeliness performed continuously. First, to acquire information through constant monitoring and complex event analysis. Second, to assess information through similarity searches and predictive analysis. Third, to apply information through decision-making and process execution. And fourth, to adapt information through results analysis and process improvement. The fifth medical practice and healthcare delivery problem is that of chaotic venues. For example, these 2 photographs depict the potential cause and effect nature of clinical chaos. In the upper left photo, one nurse is taking report from another that is possibly erroneous or incomplete because of some other clinicians, as highlighted by the red box, that are conversing in the same space in a probably audible and therefore distracting manner. As highlighted in the lower right photo, the hurried and complicated venue may lead to communication using familiar but unreliable and error-prone means, such as written notes, rather than the more reliable means, such as the electronic health record data that are readily available via the computer terminal in close proximity, as highlighted again by the red box. The sixth medical practice and healthcare delivery problem is uncontrolled experimentation. Patient care and treatment is in fact a scientific experiment conducted using the scientific method, beginning with a history and physical workup leading to problem identification and a diagnostic hypothesis, following from a differential diagnosis for a complicated presentation, and leading to care and treatment that is more or less experimental, depending on the clinician's familiarity with the presenting problem and the timeliness of pathology resolution. However, the clinical case may in fact represent two or more concurrent experiments that are interactive if comorbidity is involved, and the one or more concurrent experiments are conducted under largely uncontrolled conditions in a non-laboratory setting. Also, experimental continuity and timeliness will be complicated if one pathology, such as type 2 diabetes, is well understood and therefore subject to a sequential course of treatment, but a comorbid pathology, such as an infrequently occurring malignancy, is unfamiliar and therefore necessarily subject to an iterative course in treatment, as new diagnoses are developed and different treatment plans are executed. The seventh medical practice and healthcare delivery problem is electronic health record or EHR systems. The problematic aspects encountered are summarized by the survey results shown in this slide. Efficiency improvement impediments 42%, no significant decrease in workload 72%, and increased operating costs 54%. These disappointing results to date, following more than 3 decades of operational experience, are not surprising, given that EHR systems are designed primarily as systems of record with revenue management and maximization as their principal design goals. The necessary improvement in IT-enabled data management will be realized only by systems of engagement that facilitate real-time process management and improvement. The eighth medical practice and healthcare delivery problem is cognitive impediments. Patrick Koskari, MD, in his 2009 article entitled Clinical Cognition and Diagnostic Error, Applications of a Dual Process Model of Reasoning, identifies several cognitive impediments that affect us all, but that are exacerbated in clinicians because of the nature of their work and their typical working conditions. These include what he labels as high decision density, interruptions or distractions, circadian dysynchronicity, that is, interruption of the biological daily cycles leading to uncoordinated, conflicting physiological and psychological states within a daily time period, fatigue or sleep deprivation, and emotional perturbations, also known as affective state disturbance. Regarding sleep deprivation, it is significant to note that cognitive decision-making tends to reach its nadir at 3 to 4 a.m. daily, and some studies equate cognitive performance at that time of night with legal intoxication. Because of the 8 practice problems we have just reviewed, the preponderant symptom of current medical practice and healthcare delivery is the frequent and life-threatening occurrence of medical mistakes. Medical error can take several forms: an unintended action, either of omission or commission, an action that does not achieve its intended outcome, the failure of a planned action to be completed as intended, an error of execution, the application of a wrong plan to achieve an aim, an error of planning, or a deviation from a standard of care process that may or may not cause harm to the patient. Currently, in the United States, medical mistakes are the 3rd leading cause of patient deaths following cancer and heart disease, numbering from 250,000 to almost 500,000 deaths annually, depending on the study cited. This is an almost five-fold increase during the 2 decades since the USA Institute of Medicine report entitled "To Err is Human" was published. As of last year, medical mistakes now account for 45% of the cost of health care in the USA, approximately $1.44 trillion with a T annually. There is no mitigating end in sight for several reasons. There is no International Classification of Diseases or ICD code for errors or human or system factors. Morbidity and mortality committee minutes are subject to legal discovery. Malpractice claim settlements routinely include gag orders, and there is no uniform and mandatory investigative process such as that followed by the USA National Transportation Safety Board for public transport accident investigations. James Broslow, MD, a recently retired pediatrician, invented the eBroslow app for pediatric medication dosing calculation and administration verification. Dr. Broslow states a principal caution in medical practice and healthcare delivery to minimize cognitive demands leading to medical mistakes, that memory and mathematics must be avoided to ensure correct care. However, practitioners traditionally have ignored this advice, probably because it has seemed not to be feasible. Lawrence Weed, MD, a recently deceased American physician, researcher, educator, entrepreneur, and author of Longstanding, who is best known for creating the problem-oriented medical record as well as one of the first electronic health record systems, states in his 2017 book entitled Medicine in Denial, co-authored with his son Lincoln, that, and I quote, "A culture of denial subverts the healthcare system from its foundation. The foundation, the basis for deciding what care each patient individually needs, is connecting patient data to medical knowledge. That foundation and the processes of care resting upon it are built by the fallible minds of physicians. A new, secure foundation requires two elements external to the human mind: electronic information tools and standards of care for managing clinical information." End quote. Substantiated by the foregoing empirical and therefore authoritative observations of Drs. Broslow and Weed, I have arrived at my own conclusion about medical mistake root cause. Based on over 4 decades of work experience and observations in hospitals and other healthcare venues, and also relevant reading, including peer-reviewed articles regarding medical mistake root cause analysis, or RCA, I postulate that clinical cognitive demands exceeding significantly the cognitive capacity of humans in general and clinicians in particular creates the real root cause of medical mistakes: cognitive overload. Notwithstanding what I have just posited as the root cause of medical mistakes, cognitive overload, all currently operating medical mistake mitigation and patient safety organizations of which I am aware continue to focus on human factors such as the culture of safety, use of heuristics to aid memorization, and protocol and procedure training for performance improvement. These are cognitive-based tactics that necessarily exacerbate the cognitive overload root cause of medical mistakes, so their occurrence persists at an unacceptably high frequency. The human factors and heuristics foci are perpetuated by such organizations as the long-standing National Patient Safety Foundation, now merged as of May 2017 with the longer-standing Institute for Healthcare Improvement, educational ventures such as the Safety and Quality Informatics and Leadership Program at Harvard Medical School, academic medical center-based initiatives such as the Armstrong Institute for Patient Safety and Quality at Johns Hopkins Medicine, and more recently formed foundations for goal setting and healthcare provider with medical technology vendor collaboration such as the Patient Safety Movement Foundation. The persistent emphasis on human factors, heuristics, and process training is problematic, as typified by the need to resolve cognitive conflicts such as checklist brevity with the acceleration of medical knowledge accrual that exposes more and more complicated knowledge for migration from bench to bedside. This approach cannot effect significant progress in medical mistake mitigation. A new approach is needed. The preceding facts, conclusions, and observations lead us to this proclamation. Whereas medical and healthcare practices and procedures are critical and complicated and constantly operating, and medical and healthcare venues are extraordinarily varied, dispersed, and chaotic, and human cognitive capabilities are exceeded by medical practice and healthcare delivery demands, therefore, providers SMEs need customized IT solutions, and healthcare providers require an easy-to-use software solution to create real-time IT applications or apps. Given cognitive overload as the root cause of medical mistakes, and medical mistakes as the third leading cause of patient deaths in the USA, my vision for the much-needed IT-enabled medical practice and healthcare delivery transformative solution is encapsulated in the acronym of the copyrighted solution name, Cloud Healthcare Appliance Real-Time, which is intended to be functional and dynamic supplement to the structural and static patient chart as summarized by its acronym. Cloud, a portal-accessible solution as a service. Healthcare, designed for healthcare provider subject matter experts. Appliance, to create custom cognitive support apps. Real-time, that operate anywhere and constantly. CHART can realize these elements as identified by its acronym because it is implemented as a, quote, solution as a service, end quote, or SaaS, a term which refers to program functionality running at a cloud data center and accessible via an internet portal, much like any of the familiar retail, sales, banking, and other commercial websites. To meet the demonstrated need for a real-time IT-enabled information management solution, CHARTSaaS satisfies the requirements shown on this slide. Functional requirements referring to the non-IT healthcare provider SME's need for an easy-to-use software development environment, or SDE, to create mobile device IT applications, also known as apps, and non-functional requirements for the SDE and the apps that it creates, including that they be ubiquitous, accessible anywhere and anytime, secure, protection for code and data access, transmission, operation, and storage, reliable, that is, non-stop and no-fault operation, scalable, dynamically allocating and deallocating system resources for acceptable response times, and economical, usage-sensitive subscription billing. This information technology or IT architecture schematic depicts the several components of the CHARTSaaS solution and their principal purposes. In general, the non-functional requirements, including reliability, security per HIPAA regulations, and scalability, are satisfied by the selected cloud service provider or CSP services as enclosed in green. The CSP managed Internet Accessible Data Center, also known as a cloud data center, provides services for secure connection to other Internet-attached sources and devices, commonly referred to as the Internet of Things, or IoT, depicted in red. The functional requirements provided by components enclosed in blue include the cloud-based CHARTSaaS software development environment that itself includes services for interoperability with CHARTSaaS subscribers' on-premise IT systems and data sources, such as its EHR system. Using the CHARTSaaS SDE, the subscriber's authorized users create applications that can be uploaded to an app store, ready for use, and downloaded to run on a user's mobile device, all as shown in red. To enable healthcare provider SMEs to create cognitive support mobile apps, the CHARTSaaS SDE includes 8 features. 1. Subscriber and user and artifact administration. 2. Rules-based or Boolean decision descriptions. 3. Process and case management description. 4. Data device interoperability description. 5. Bayesian or multivariate analytics description. 6. Mobile device administration and management. 7. Knowledge, archiving, and access management. And 8. Operations management and app optimization. Access to the Cloud Healthcare Appliance Real-Time Solution as a Service, or CHARTSaaS, software development environment requires a four-step procedure. 1. A prospective CHARTSaaS subscriber completes the registration form at CHARTSaaS.com and submits it electronically. 2. The prospective subscriber receives an email of approval and acceptance, including disclaimers, some instructions, and login credentials. 3. The now approved subscriber surfs to CHARTSaaS.com, the sandbox page, and logs in. And 4. The subscriber views the software development environment desktop and clicks on a feature icon to begin app development work. This slide depicts the screens used for describing a process at upper left and also a case at lower right. The Process Design tool implements the familiar swim lane flowchart paradigm, in this case to describe a failure to rescue mitigation process. And the Case Description screen implements the folder paradigm to aggregate discontinuous but related processes that include unpredictable human interventions and/or wait times, as would be the case with a health insurance claim. For process and case management, decision management, and various other process administrative and optimization features and functions, CHARTSaaS will capitalize on the free and open source software, or FOSS, developed by the Camunda Corporation, founded in Germany in 2008, having websites at camunda.com and also .org. The Camunda software suite is available in the FOSS Community Edition for free use and incorporation in other software solutions by independent firms, or in the Commercial Enterprise Edition. EE includes, for a use-dependent price, a more full-function feature set for technical operations and also for support, maintenance, and training services. Camunda implements a three-click method for migration from design time diagrams such as those shown on this slide and the next to runtime code without the need for IT expert support, which implements, for the most part, the main value proposition of CHARTSaaS. An easy-to-use software tool for healthcare subject matter experts, or SMEs, to create cognitive support apps with minimal cost and complexity. This method is predicated on the internationally recognized object management groups BPMN, CMNN, and DMN modeling notation standards. This slide depicts the screen used for describing a multi-condition and action decision, also incorporating applicable OMG standard DMN as implemented in FOSS software from Camunda. The two-dimensional table format includes rows that each define a decision parameter by name, the threshold, nominal, or other critical value against which the decision input value is to be evaluated, and the one or more actions to be executed depending on the evaluation. For example, this approach is adequate to monitor a diabetic patient's A1C level for inclusion in process to notify the healthcare provider and the patient regarding insulin regulation. Alternatively, required actions could be defined in named columns in order to include several parameter value evaluations, as would be needed to monitor relevant physiological parameters needed to detect and prevent a septic patient's progression to severe sepsis or to septic shock. This slide depicts the sources for a screen to be developed for describing the interoperability between a CHARTSaaS process activities and the sources of data required to execute those activities. The long-standing HL7 connectivity standard for transfer of clinical and administrative data between software applications used by healthcare providers has been extended in recent years to include the Fast Healthcare Information Resources, FHIR, or FHIR. This specification, as described at its website, and I quote, leverages existing logical and theoretical models to provide a consistent, easy to implement, and rigorous mechanism for exchanging data between healthcare applications with built-in mechanisms for traceability to the HL7 Records and Information Management or RIM standard and other important content models, end quote. FHIR defines logical resources that, quote, satisfy the majority of common use cases, end quote. Recently, major EHR vendors such as Epic and Athena Health have begun implementing libraries of application programming interfaces, or APIs, that enable access to healthcare provider customers' EHR systems to obtain and provide information without risk of corruption to the stored data or code. The CHARTSaaS software development environment will leverage both of these facilities to enable connectivity and interoperability between SDE-built apps, the CHARTSaaS subscribers' EHR system, and other internet-accessible data sources. This slide depicts a screen that defines and provides access to several mobility-related parameter and value definition screens, including authorized users, locations, processes to be included, devices or operating systems such as Android or iOS to be targeted, and permitted access to so-called back-end systems such as the subscriber's EHR system. The software to implement mobile device features has yet to be determined. This also is the case for the Bayesian and multivariate capability for similarity and predictive analytics, both of which are central to automation of use cases such as differential diagnosis and treatment planning. Speaking of use cases, that is, candidates for automation using a chart SDE, there exists a virtually infinite number. However, most include one of the 4 persistent subprocesses that recur frequently in medical practice and healthcare delivery and that exceed human cognitive capability and that therefore lead to patient morbidity and mortality. First, failure to rescue, or FTR, patient preventable deaths owing to a clinical complication not recognized in a timely manner or treated appropriately. 2, constant monitoring, observation of patient disease condition or one or more medical parameters over time. 3, alarm alert fatigue, desensitization to alarms and alerts owing to exposure to a high number of frequent alarms. And 4, handoff communication, or HOC, transition of care and patient-specific information from one healthcare professional to another. A fatal example of the HOC use case was reported to the Joint Commission as a so-called sentinel event per TJC accreditation requirements and published in the April 2015 issue of the TJC publication named The Source as follows, quote, a healthcare system submitted a root cause analysis, or RCA, to the Joint Commission for a sentinel event that involved a patient whose blood levels were not drawn frequently enough to monitor the thinness of her blood while receiving a continuous heparin infusion. The patient had been started on heparin infusion on an orthopedic unit and then was later transferred to a cardiac unit. The order set for the heparin infusion was not entered properly, leaving out the automatic order for blood tests every 6 hours. During the handoff report, the nurses did not discuss when the next blood test would occur to monitor the heparin infusion. For 24 hours, the patient went without blood tests until an oncoming nurse questioned the situation during a handoff report. At this time, the off-going nurse also reported that the patient had been complaining of a headache for several hours. A computerized tomography, or CT scan, showed intracerebral hemorrhage. When the patient's mental status deteriorated, the family chose not to proceed with surgery due to the patient's multiple comorbidities and recent decrease in quality of life. She expired 3 days later, end quote. Handoff communication errors are the leading cause of medical mistakes, and therefore they must be mitigated to effect a significant reduction in instances of patient morbidity and mortality overall. Because the HOC process has risen to the level of a sentinel event in the eyes of the Joint Commission, but with no TJC recommended mitigation tactics other than attention to human factors and heuristics, which, as we have seen, merely exacerbates the cognitive overload root cause of medical mistakes, it is potentially the most productive example for demonstrating the value of real-time cognitive support apps created using the CHARTSaaS SDE. This slide depicts the fatal handoff communication sentinel event previously described, using the swim lane flowchart paradigm with 5 rows to depict the activity of the 5 actors: the patient, the healthcare physician provider, nursing staff on the post-operative orthopedic nursing unit 1, and nursing staff on the receiving cardiac nursing unit 2, and the electronic health record IT system. Also included are 7 columns to depict the 5 events included by the beginning and ending of the process flow. This slide employs the swim lane flowchart paradigm once again to depict the sentinel event previously described as it would have occurred with a CHARTSaaS HOC app in operation, the app being depicted in the added swim lane at the bottom of the flowchart as enclosed in green. The app operates continuously and is designed to monitor the occurrence and content of updates to the EHR patient record, and then to report problematic events. In this case, the app would deduce that the required blood type 1 heparin-induced thrombocytopenia or type 1 HIT test had not been performed within the 6-hour time interval since the previous test, because the app did not detect the occurrence of an update to the patient's EHR case record type 1 HIT test result data field. Therefore, the app would notify implicated clinical staff member or members via their associated mobile and/or other digital devices of the emergent need to perform the ordered test and to read the results. Thereby, the medical error of omission would have been avoided and the patient's life saved. This slide includes representations of the 3 handoff communications app screens. The left-hand image, designed for patient or nursing unit designation, the center image, if the user designates a nursing unit, for automatic display of the current patient roster on the designated unit from which the user can select a specific patient, and the right-hand image for display of the selected patient's pertinent data, which in this case are organized according to the Situation, Background, Assessment, and Recommendation, or SBAR heuristic. Data pertinent to the monitoring of potential type 1 HIT, the values of which are approaching lethal limits, and/or urgent actions to be taken, are displayed in red. As you can see, the CHARTSaaS software development environment enables healthcare provider subject matter experts to create customized, cost-effective, and potentially life-saving apps, such as Handoff Communications app. These apps are created and operated with minimal operating expense, no capital cost, minimal IT complexity, and little or no impact on the CHARTSaaS subscribers, healthcare provider organizations, IT systems, or staff resources, all because of the cloud-based portal and subscription modalities of operation. In conclusion, per the objective of this presentation, I hope first that you can appreciate real-time information technology-enabled cognitive support as a requirement to accomplish complete, accurate, timely, and cost-effective medical practice and healthcare delivery with minimal mistakes. Second, that you will associate with CHARTSaaS LLC to support CHARTSaaS development, completion, and launch as a usage-sensitive subscription service for licensed and accredited healthcare providers. And third, that you will apply CHARTSaaS or a similar IT solution in your practices and organizational operations to obtain significant improvement in lifelong personalized health maintenance, medical mistake mitigation, medical case outcomes, operational economy, efficiency, and effectiveness, and acceleration of knowledge accrual and application. I very much appreciate your valuable time and attention to consider the Cloud Healthcare Appliance Real-Time Solution as a Service, the CHARTSaaS purpose and scope, and its transformative potential. Please contact me via email or phone at your earliest convenience to discuss and decide how you may participate in realizing this disruptive IT solution for the positive transformation of medical practice and healthcare delivery. Thanks again, and good wishes for another great day.